Assalamualaikum warahmatullahi ta'ala wabarakatuh, and once again good day to each and everyone. Okay? So ngayon, no, week 2 na naman tayo. Okay? This is actually allotted for only 1 week, no? Starting from June 28 to July 2. Okay? So yun, no, last week, no, we begin on our week 1. Okay? Then natapos na naman natin yun. So again, we have to proceed here sa week 2 natin. So if you have any question about our sorry. Okay? So if you have any question about our topic last meeting, you can ask me, okay, directly. Okay? So yun. So once again, this is introduction to environmental engineering. Okay, so yun. So again, our topic for today again is continuing our topic last meeting, no, that is mass and energy transfer. So once again, since we are we are concerned about the masses and energy of the environment, no, in out or environment surrounds us. So kailangan talaga nating pag-aralan yung properties and concept behind mass and energy. Okay? So yun. Now, number 3, we have here material balance. Okay? Since in here, no, in our environmental engineering, most probably we are considering our surroundings as a whole system. Okay? Sabi nga sa thermodynamics, no, if we don't have or we cannot actually have the properties of the we cannot actually have the study of a certain things if we don't consider that particular things as a system. Okay? So kailangan i-consider mo muna natin yung i-consider mo muna natin yung surroundings natin as a system para malaman natin kung ano yung nagbabago or ano yung constant or ano yung consider natin na parameters na magdi-define doon sa system na yon. Okay? So yun. So one properties regarding that one is itong si material balance, no. So we need to balance or we need to take the balancing of the materials that will go inside or outside the system. Okay? So in here we have here control volume or control boundary, then meron tayong inputs at the same time meron tayong output. Okay? So sa inside na system na yon, meron tayong accumulation and meron din tayong decay reaction, which is it's either decay or generation. Okay? So dalawa yun siya. Okay? So may mga cases na wala tayong may mga cases na wala tayong reaction, pero may mga cases naman na wala tayong accumulation. So depende yan siya sa system. Okay? Usually sa mga problem, ang binibigay na condition is it's either wala tayong reaction or wala tayong accumulation. So ibig sabihin nun, pag wala yung dalawa, ang consider na lang natin is yung input doon sa system na yon at saka yung output doon sa system na yon. Okay? So yun. So usually, no, when we are talking about the system, ang pwede na lang natin gamitin na equation is itong equation number 12. So meron tayong accumulation rate is equal to input rate minus output rate plus reaction rate. Okay? So yan yung gagamitin natin. Okay? So okay? Now, in here, no, for example, wala tayong accumulation rate. So ang nandoon lang is yung reaction rate. Ang mangyayari is that yung input natin, no, either yung output natin is pwedeng matranspose sa kabilang side. So ibig sabihin yung output natin is equals to input rate plus the reaction rate. Now, kung wala naman tayong reaction rate, ang mangyayari dito sa equation natin is kung i-transpose natin itong output rate sa kabilang side, yung input natin is magiging equal siya sa accumulation rate plus output rate. Okay? So kung wala yung dalawang to, ang mangyayari dito sa equation natin is input rate is equal to output rate. So, ibig sabihin, wala nang mangyayari doon sa system natin. All we have to do is to consider the input rate at saka yung output rate natin. Okay, by the way, when we are talking about reaction rate, ito yung nangyayari sa loob ng system if the system itself is considered as a ano yun? Tingnan ko muna. Considered as a dito, sabi dito, the reaction term does not imply a violation of the law of mass. Okay, wait lang. Tingnan ko muna. Ayun, tama. No? Frequently, it will can be simplified. The most common simplification result when steady state or equilibrium condition can be assumed. No? So, if the system is in steady state or equilibrium, simplification of equation 12 can be done. Okay? So, ang mangyayari is, pag steady state ka or equilibrium ka, wala tayong accumulation. Okay? Or there is no accumulation rate. No? Ito, mawawala ito. So, once again, pag yung system mo is in equilibrium state or steady state, wala tayong accumulation rate. So, tandaan yan, ha? Okay? So, again, no? Pag meron naman tayo, pag yung condition naman natin is that conserved, no? Conserved, ibig sabihin na conserved yung system natin, ibig sabihin nun, wala tayong reaction rate. So, ibig sabihin, yung system natin is conserved. Okay? So, walang nangyayaring reaction sa loob ng system. Okay? Walang nangyayaring reaction between the chemicals or substances. Ibig sabihin, wala tayong nangyaring reaction. So, ibig sabihin, wala itong term na to. Okay? So, yun yung mga cases. Okay? So, yun. So, basahin na lang natin to siya. Nandun yun. Okay? So, if we consider as a steady state conservation, so ito yung magiging equation natin, no? So, meron tayong CSQS plus CWQW is equals to CMQM, okay? Or we can say that input rate is equals to output rate plus the nangyayaring reaction sa loob ng system, okay? So, yun. So, ito yung equation number 14 natin, okay? Now, just like for example this one, so basahin na lang natin tong example. So, actually, this is just the application of what I have said kanina. Okay? So, yun. So, basahin lang natin yun siya. So, I think that's all. If you have any question about this topic, you may just have to ask it to me right after this. Right after yung mapanood itong videos na to. Okay? I mean video na to. So, that's all. Assalamualaikum warahmatullahi ta'ala wabarakatuh.